This short video will show how to create a TCP server from within StarDraw Control. So we'll add a product. We'll go and choose the generic control manufacturer. We'll call it TCP Server, and we'll call it My Server. Okay, we'll go and add a port. We're going to call it TCP, and you will see that there's a new port type called TCP Server. And if we click into Edit, you will see that the default script for this simply inherits from a new class called TCP Listener. The constructor should go and set the default port, the TCP port that it listens on, and you can set the new line character as to when you get an end of line, what the characters are to determine end of line. The default is carriage return line feed. You also get some overrides. On client connected is called whenever the client is connected, and you're passed in a client context which you can go and store state information in context.userState. You also get called when the client disconnects, as well as when a byte comes in for that client and when a line comes in for that client, and again the line being determined by a string of bytes terminated by the new line string. So first thing we'll do, we'll go and create a property for this driver which will be updatable over TCP. So we'll go and call this volume, and we'll go and initialize it to 0. We'll also go and have a controllable property, public int volume with a capital V, and for the get we'll go and do something like return the volume. However, we have to be careful here because this is going to be a multi-threaded server, because we could have multiple clients accessing the server at the same time on different threads. So we have to put locking around critical resources. And it's very important that the lock is only around a very small piece of code, otherwise you will get deadlocks. So we'll just lock this and we'll go and return the volume. Okay, that's the get. And on the set, what we'll do, again, we want to lock around this. And if the volume hasn't changed, so if the volume equals the value that's passed in, then we'll just return. Otherwise, we'll go and set the volume equal to the value, and we'll go and drop out. So at this point, we are outside of the lock, and the volume has been updated. So we're going to go and fire the volume changed event. So to do that, we need to have a controllable public event handler on volume changed. This is very similar to previous videos recorded on this, and what we'll do is we'll say if on volume changed is not equal to null, then go and fire the on volume changed event, passing in this and the standard event args.empty. Wonderful. And we'll go and finish the set and finish the volume. Let's make sure this compiles. Yes, it does, miraculously. Now, the other thing we want to do is whenever the volume changes, we want to go and inform all the currently connected clients that the volume has indeed changed. So what we're going to do is we're going to loop through all the client contexts. Client context. So that's of type client context. We'll call it context in, and there's a new base variable called client contexts. Note the S there. And what we're going to do is go and call context.writeLine, and we're going to format a string, and we'll say vol equals passing in volume. And again, notice the capital V there, because that's going to come into here, and then call this lock. So it could, in theory, have been updated between this lock and this sending out. but it's okay because we just want to send out what the current volume is. Right, so that's how to set the volume. And this is all standard. This has really got nothing to do with the TCP server except for this bit here. Great, so now we're going to go and implement some of our protocol. We're going to look inside online in, and what we'll do is we'll have a switch statement on the line that's coming in. And we'll say if it's quit, then what we want to do is call context.close, and we're just going to close the connection. Okay, so we can exit very easily. And if the string that's come in is vol ? Then we're going to say that wants a response of what the volume is. So we're going to here call context.writeLine string.format vol equals passing in volume, and we'll call break and end it there. Great. Now we want to go and set the volume through these protocols. So what we'll do is we'll say, well, if it's not quit or vol ? We'll catch the default and we'll say, well, if the line starts with vol equals, then we want to come in and try and get the value. So because we don't know what's being passed to us and we're going to have to process it, we should have some defensive programming and put this in a try-catch statement. So we'll say volume equals int.parse line.substring of, now that's 0, 1, 2, 3, 4. So from the 4th character onwards, parse that, and that sets volume with a capital V. So again, that will come into here. It will be locked, so we're completely multi-thread safe, and it will go and fire an event and go and update any concurrently connected clients. So that looks good. We'll go and finish this off, and we'll go and catch the exception. And what we'll do is we'll write back to the context that there was an error equals surround that by string.format and ex.message, so we can actually look at the message that's passed back. Okay, so we can also go and log it onto the debugger with this new log debug of the we'll just do the ex.message of what's come in. Right, so we need to end that catch, and we need to finish off that default with a break. Great, so that's the whole driver written that is multi-threaded, got a volume property that will fire an event and update any clients with any changes. So we'll say okay, won't bother sharing that, and now I'll go and drag this in and go and connect it to the Ethernet port. Wonderful. You will also see that on the TCP port it has a connection backlog, so you can actually specify how many connections are pending at maximum. So if you're logging, when you've got a backlog of connections that are coming in, specify maximum, and you can also specify the port at design time. So now I'll go and design some user interface. We'll just do a level slider, and I'll resize this, and what we'll do when this changes, we want to go and set the device of the TCP server, and we want to go and set the volume to come from the level slider value property. And we also want to go and catch the TCP server on volume changed event. Yes, we do want to save those actions. And we want to go and update the level slider value property to come from the volume property on TCP port there. Great, so now we will go and run this. You can see I'm actually running in demo mode, so everything I'm doing here you can do with the demo download from our server. and it switches us into debug, and here we can see the UI and the events being fired here. So I've just got a little command window, and I will telnet onto 127.0.0.1 on port 6000. So that's a special IP address that is the loopback address, so whatever IP address you have on your machine, 127.0.0.1 will always come back to you. And I will type in VOL ? And you can see on the debugger that from that port we've got a line received, volume ? And what was sent back is volume equals 66 because we set it up here. Now I'm going to set vol equals to 100. When I hit enter, you can see that we get a response back of vol equals 100, and an event has been fired, and the UI goes and updates in the user interface. And if I change it here, it updates on the client. And in fact, if I go and bring over another window and do telnet to the same port, if I go and update the UI again, both are updated from the UI. And if I update here, vol equals 0, it updates both on the UI and in this client, and then in this client. And again, vol equals 100, updates the UI and updates this client as well. And I can quit on this one, and I can quit on this one, and exit here. So you can see with just a few lines of code, we actually have a full-blown TCP server that is multi-threaded safe, that can have any kind of protocol that you want to define and you can parse, that can fire any number of events, that can have properties which are locked, so they are thread safe, and even feedback to other connected clients, so you can effectively give unsolicited responses back to your connected clients. That's it.